For each integer n greater than 1, let f at n be the number of solutions of the equation sine x is equal to the sine of nx on the interval 0 to pi. What is the sum from n equals 2 to 2007 of f at n? So we have to figure out from 2 to 2007 f at n. So what I'm going to do is I'm going to make a table of n and the number of solutions, and I hope this will give me some sort of a pattern, and then at the very end I can add up all these numbers. Now let's start with n equals 2. If n equals 2, this is my equation. Sine of x is equal to the sine of 2x. So if I plot sine of x and the sine of 2x on the same graph between this interval only, 0 to pi, 0 to 180 degrees, the number of intersection points will be the number of solutions to that. So I will show you those two graphs plotted on the same graph. And this is that graph. We've got sine of x and we have the sine of 2x. Sine of x is this one right here, and the sine of 2x is this one. So how many times do they meet, intersect? One here, and one here. So there are 3 intersection points between these two graphs. So when n equals 2, the number of intersections is 3. So go back and fill that in the table. So I'll put a 3 right here. So that was for n equals 2. Now in a very similar way, let's look at n equals 3. That would be the sine of x equals the sine of 3x. So now I have to look at these two graphs, the sine of x and the sine of 3x on the same plot, and see how many intersection points we have. And this is that graph. We've got the sine of x and we've got the sine of 3x. And the number of intersection points between 0 and pi, 1, 2, 3, 4. So those 4 are going to be placed in my table. For n equals 3, the number of solutions is 4. Now, n equals 5, or 4 rather. Next one. Sine of x is equal to the sine of 4x. How many intersection points? Here's the graph. The number of intersection points this time, 1, 2, 3, 4, and 5. So when n equals 4, we've got 5. So let's keep doing this. For n equals 5, we have sine of x is equal to the sine of 5x. Let's look at that graph. And this graph shows us 1, 2, 3, 4, 5. Only 5. Why? Because this is a key to this question. Whenever we have both the sine of x and the sine of nx have a value that's equal to 1, it's going to be common in the very middle right there, and therefore there will be a symmetric number of points on either side. So for n equals 5, this was only 5. You notice it was going up by 1 every time. 3. When n equals 2, it's 3. When n equals 3, it's 4. When n equals 4, it's 5. But for 5, it's only 5, because that's a key point right there. Let's keep going here. N equals 6, which is sine x is equal to sine of 6x. And we have sine of x is equal to sine of 6x. 1, 2, 3, 4, be careful, 5, 6, and 7. So 7 intersection points there. N equals 6, we've got 7 intersection points. Now let's go to n equals 7, which is the sine of x is equal to the sine of 7x. And from this graph we get 1, 2, 3, 4, 5, 6, 7, 8. 8 intersection points. The next graph will be the sine of x and the sine of 8x. And the number of intersection points here is 1, 2, 3, 4, 5, 6, 7, 8, 9. And we'll look at a couple more. This is the next one. The sine of x is equal to the sine of 9x. And the number of intersection points here, 1, 2, 3, 4, 5, 6, 7, 8, 9. And why is it 9? Usually it's like one more than the n value. Why? Because again, we have that point where both of these graphs have a value of 1 in the very middle of the graph. And similarly, when you have the graph of sine of x and the sine of 13x, you again get a similar situation. Why? Because both of those graphs have a value of 1 in the very middle. So this gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 intersection points. So 13 intersection points when n is 13, 9 when n is 9, 9 intersection points when n is 8, and 8 intersection points when n is 7. Let's fill those in the table. When n is 7, we have 8 intersection points. When n is 8, we have 9 intersection points. But when n is 9, we had only 9. And when n was 13, we had 13. So basically, when it's 10, it'll be 11 intersection points. When it's 11, it'll be 12. When it's 12, it'll be 13. But whenever it's 5, 9, 13, the number of intersection points is the same as n. So what that means is whenever there's a number that if you subtract it from 1, it'll be divisible by 4, you'll get this kind of scenario. So for example, 5 minus 1 is 4, which is divisible by 4. 9 minus 1 is 8, which is divisible by 4. 13 minus 1 is 12, which is divisible by 4. So if you keep doing this all the way down, dot, 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 we have to go all the way until 2007, right? According to this formula. So you're going to get, let's say, all the way down to 2004, 2005, 2006, and then eventually the very last one, 2007. Now, which one of these numbers matches these guys? Well, it would have to be a number that when you subtract 1 from it, it's divisible by 4. And that is this one right here. Because 2005, if you subtract 1, is 2004, and that's divisible by 4. So the number of solutions for 2005 will be 2005. Remember, it matches. See how those match the n number? But for everything else, it will be one more. So this will have 2005 solutions, this will have 2007 solutions, and this will have 2008 solutions. Okay? So now my task is to add up all of these guys. I have to add up this whole column right here. Okay? So that's basically very similar to the following. It's like saying 1 plus 2 plus 3 plus 4 plus 5, dot, 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 all the way until 2008. But not exactly that, right? Because first of all, I don't have a 1 and a 2. So I've got to get rid of the 1 and the 2. It starts with 3. And then I have to take into consideration that these guys kind of are out of place. They are 1 less than this right here. So that means every time a number is divisible by 4, if you subtract 1 from it, we're going to have 1 less. See what I mean? So how many of these guys are there? How many of these numbers are there? Well, that shouldn't be hard to figure out. basically 2005 minus 1, which is 2004. I have to divide that by 4, and that gives me 501. So there's 501 of those numbers that are an exception. And each of those brings down this total by 1, right? Because when it's 5, it brought it down from 6 to 5. When it's 9, it brings it down from an expected 10 down to 9. When it's 13, it brings it down from an expected 14 down to 13. So each of those 501 numbers brings the total down by 1 if we were to make it perfect like that. So I've got to subtract 501. And that is my sum. So here we go. This one I can just do with that formula, n times n plus 1 over 2, where n is 2008. And then I'm going to subtract 1 minus 2, which is 3, and then subtract 501. All right? So this should give me the answer. So I've got 2008 times 2009 divided by 2 minus 504. And that is equal to 2,016,532. So therefore, the answer to number 24 is D.